My new game is basically shader programming in disguise. Or put differently, I took what I love about writing shaders for video games and simplified it into a puzzle game that's a little bit like Picross 3D, but with code. The game is called Replicube, and there's a demo live today on Steam, so if that little pitch already got you interested, hop over and try the demo. Otherwise, stick around and I'm going to show you the game and then explain the logic and inspiration behind it. So again, the game is called Replicube. With each puzzle, you're presented with a 3D object made up of tiny little cubes called voxels. Your job is to replicate this object by writing simple code to generate it. This is what the main interface looks like. The game takes place within a little virtual OS, inspired by early graphical operating systems like OS/2, early Windows, Mac, etc. On the left is where we write code. In the upper right is the target object, and in the lower right is the object that's generated from our code. So you can see if I just type return 7, then the whole model gets filled in with voxels and they're bright red, which is the color 7 down here from the color palette. So if I change it to return 11, we get green. If I change it to return 0, we get emptiness because 0 or any number less than 0 represents empty space. Okay, but if I can only return one number, then how can I make an interesting object? Like my goal here is to make this table, but I'm only returning one number. It just fills in the whole thing. Well, the secret of this game is that your code is not run just once. Your code is actually run multiple times individually for every single little tiny voxel in the whole object space. So I can actually return different numbers depending on which voxel we're talking about. How do I know which voxel we're talking about? Well, the game sets up variables, X, Y, and Z, that tell you the position of the current voxel. So when my code is running, I can look at those values and do something. So for example, I could say if Y equals 0, then return 2, end. And now my code is only going to return 2 when Y is equal to 0. And so now you can see all we did was just fill in this one spot right here. Oh, actually, look at this. We're making great progress towards our table. I'll change this to, what's the color of the table? Okay, the table is color 15. So let's change this to a 15. All right, we're partway there. Now we just got to figure out the legs. So let's take a closer look here. The legs are at, okay, this one's at -2 on the X. It's got different Y values, but it's -2 and 2, X and Z. And then this one is 2 and 2, but different Y values. Okay, this one is 2, -2. This one is -2, -2. Okay, so if I kind of look at it like this, we can see that the legs are always at 2 plus or minus on the X and 2 plus or minus on the Z. Okay, so for example here, I could just say, if X equals 2 and Z equals 2, then return 15. Let's see what that does. Okay, so look, we got kind of the right spot. We got the positive values, right? X is +2, Z is +2, and right now all the Y values are allowed, right? We didn't care about Y, so we don't want to put the legs up above here. So we had this thing here, so let's add a thing right here. We'll say if Y is less than 0, then, and we'll put all of this inside that. Okay, there we go. Oh, now wait a minute. I have the table at 0, but if we look closely here, the table is actually at Y equals 1. So we got to go up here and say, okay, this should be a 1. Boop. And then this could be less than 1. There we go. Okay, so now we just need our other legs. So, I could definitely do this by hand. I could say, okay, what about also if X equals -2 and Z equals 2, then return 15, and we got 2 legs out of it. And I could keep going like that, but of course, this is code. In fact, this is Lua code. So anything we can do in Lua, we can do here. And we can maybe bring out some math functions. Like for example, there's a function called absolute value, ABS, which basically says, I'll give you a number, give me its absolute value. Maybe you remember that from math class. So negative numbers get flipped around to become positive because it just tells you like how big is the number. So -7, the absolute value of that is 7. So it's kind of a way of saying, take all the negative numbers and just consider them their positive counterparts, right? So I could actually go like this, get rid of this, and I could say, give me the absolute value of X. So now this would be true if X is 2, or if X is -2, because the -2 becomes a +2 and then matches. So now when I run this, we get 2 legs for the price of 1. And we could do the same thing for Z and run it. And we solved our puzzle. We made a cute little table with code. The main goal is simply to work out the code to generate the target object and then move on to the next puzzle. But there's a secondary goal in the game, which is to optimize your code. And actually, each puzzle in the game comes with 2 leaderboards. One about optimizing code size. Can you recreate this same object using less code? And another one about code efficiency, which is cycles, which is basically, can you make your code use less instructions, operate more efficiently to produce the same object? You can see here in this case, we have a little histogram, and I'm doing pretty good on both. I'm kind of in the middle here. I'm down in 13th place on code size, and I'm 12th place for cycles. Anyway, if you've ever tried coding a shader for computer graphics before, some of this might seem familiar. In a graphics shader, you are essentially writing a small amount of code that is run for every pixel of an object on the screen, and working out what color should this specific pixel be. I absolutely love writing shaders. I jump at every chance to write some for each game I work on. I think it's the most satisfying form of writing code and utilizing math. Each tiny change to the code produces an instant visual result on the screen. This quick feedback loop makes coding feel less like engineering and more like sculpting, iteratively adjusting and refining something until you get the result you're striving for. I hope players playing this game will experience a similar feeling, almost like they are sculpting with code and math. Anyway, there's a lot more to say about the game, especially its surprisingly excessive online features where players have a whole forum built into the game where they can discuss tips and tricks. They can even share their own creations that other players can then download and challenge, just like a puzzle, with leaderboards for player-created creations and everything. But the important thing to know is that there is a free demo of Replicube available on Steam today. Give it a try, and I'd love to hear what you think of it. So yeah, hop over to Steam, try the demo. The link's in the description of this video, and bye!